In this video, we're going to look at three-figure bearings. To start off with, we'll go through the basic rules and then we'll move on to some questions that involve bearings. So let's start off with the rules. So rules for three-figure bearings. We need to measure from north. We need to measure clockwise and our answer must have three figures. So for example, if we measure an angle of 60 degrees, it would be 060 degrees if we're given now a three-figure bearing. Okay, let's look at some typical questions we might be asked. So we're told a rough map of the USA is shown below. We need to find the bearings of, and we'll do part A first, Miami from Memphis. As soon as you see the word from, you're going to put a north line at this point right here. And in this case, that's Memphis. So what I'm going to do is grab a north line. So Memphis is just here, and that's where my north line is going to go. I'm now going to get a line connecting Memphis and Miami. I want to measure now the bearing. The bearing is measured clockwise from my north line and it's going to have an answer with three figures in. So here is my north line and we can have that just there. So north line is just here and I'm interested now in this angle right here. So we're coming round from the point and we just have to measure this. So with the protractor we can move this into place. So I'm going to put that on my north line and I'm going to measure round the top. So we can see starting at 0 we go round the top. Now that looks to be around here, which is about 128 degrees. So I've measured around the outside and it looks to be about 128 degrees. So what I can say then now, and I'll write this on, the bearing of now Miami from Memphis is going to be 128 degrees. Now, if this was the other way round and I was asked to find the bearing of Memphis from Miami, now my north line would go at Miami and I would measure round the other way. Later in the video, we will look at angle facts that allow us to calculate this without measuring for the second time. But for now, what I'll do is just show how we would do this. So now if I wanted, remember this is the north line and it's going to be parallel to this line. If I wanted the bearing of Memphis from Miami, I would be measuring from north and I'd measure clockwise. So what I do, I come right the way around here. Later on in the video, we'll look at different ways of finding this. But for now, what I could do, let's say I hadn't already found this. I've got two choices. I could measure around the outside, or I could measure this part and subtract it from 360 degrees. So let's look at doing that. So what I'll do, I'll just turn this round. Let's move this into place. And what I'm going to do now is measure this angle right here. Now if I look at the angle here, up to that line, let's get that in place just there. That looks to be about, if I read on the inside, about 52 degrees. So if I hadn't worked this one out, what I could say now, let's just write this in. This angle here is going to be 52 degrees, give or take. Therefore, the bearing is going to be measured around the outside. That would be 360 degrees minus the 52 degrees, as we want all of this angle right here. So that's going to give me now 308 degrees, and that's approximately the value. As stated, we'll see a nice, easier way of doing this later on. So with that one, what we could do, if we wanted, is add 180 here and measure this angle, or simply subtract now the acute angle, the smaller one here, from the 360. Okay, let's have a go at another one of these. So let's have a go at, let's do C. Los Angeles from Detroit. I've seen the word from, therefore my north line is going to go at Detroit. So there's Detroit, and I want to find now Los Angeles. Los Angeles is there, so let's connect those two up. So now I'm interested in the angle, and I'm measuring now clockwise from Detroit. So I want this angle right here. So what we're going to do is measure around here, and this will be the bearing of Los Angeles from Detroit. So let's put my north line just here. That's my north line, and I'm going to measure clockwise. I'll give it three figures, and we're coming down this way. Now again, with this particular one, I could now just draw a line down here. We know a straight line, angles on a straight line equal up to 180. Therefore, I could measure that line. So if I just, and I'll show you how you could do this. If I just extended this line just here, we could measure this angle and add it to the 180. I prefer to measure this angle, which is either going to be an acute or an obtuse angle, and subtract it from 360. So let's put this in place and we'll spin it round again. And I'm just going to measure the other way round. So here I've got now my protractor and it's on there, and I'm going to measure, remember we're measuring on the inside now, I'm measuring this angle, that looks to be about 102 degrees on the inside, give or take. So what I could say now is if this is going to be 102 degrees, and I can write that on, that angle right there is 102, therefore the bearing, if we consider now, this is going to be 200 now and 58 degrees. So that is the bearing as I've measured round the outside, technically. Or I've just said I'm going to subtract that away. Don't get caught in the trap of saying that the bearing is 102 degrees. I've simply now done 360 minus the 102, which is going to give us 258 degrees. It just makes it slightly easier. Sometimes now if you have, and I'll just show you this, if you have a more snazzy protractor, what you can do here, let's just move this back into place. You can now, if we turn this round, let's spin this round. Let's grab that and turn it round. We could, at this stage now, get one of the 360 ones and measure it like so. So if you have one of these, and let's spin this to the point where we want to come up here, let's put that at 0 degrees. Then what you can do is put this in place. Right, let's grab it and move it. Okay, there we go, that's what I want. And we could measure that round here. Now we can see that that is pretty much 258 degrees measuring around the outside. I appreciate though that not many people have the 360 degree protractors. So there we go. That's now reading off a bearing from a map, and it's important to understand as soon as you see the word from, that's where your north line's going. Okay, let's change things up and we'll look at a slightly different style of question. So, on this one, we're asked to draw diagrams to show the following bearings. So, A is 0, 4, 0 from B. So let's go ahead and draw B. All I'm going to do here is put B, and this is from B, therefore my north line is going to go just here. So what I'm going to do is put this up, and that is going to be my north line. In fact, let's change the colour of that as that doesn't look too good. So let's grab that up, and that will now be the north line. Okay, we're told that A is on a bearing of 0, 4, 0 from B. So all I'm going to do now is put my protractor in place, and that'll be just there. So I'm going to come around here and look and find 0, 4, 0. 0, 4, 0 is a 40 degree angle, and that is just there. So all I've done is marked it. There's B, and 40 degrees is there, measuring round the top. So let's take this out of the way, and then all I'm going to do at this stage now is connect this up, and this is going to give me what I want. That is a 40 degree angle. It's a bearing of now 0, 4, 0, and we'll write that on. So here is A. Let's put A just here. So that is A, and this now is the north line. That's north, and this now is the bearing of 0, 4, 0 degrees. Okay, let's try another one. Let's go for this one right here. C is 325 degrees from D. Okay, so let me put now D just here. Let's put D just here. So from D, that means I'm going to have a north line at D. So let's put the north line at D. With this one, we're 325 degrees from D. So I'm going to be measuring clockwise round this way. Instead though, what I'm going to do is spin this back round and subtract 35 from 360 degrees. So if I consider now, what I want is a bearing of 325. So I know that a complete revolution is going to be 360. So all I need to do now is measure out an angle on the inside just here of 35 degrees. So if I do that, that'll be just there. I can move this out of the way. Let's get that out of the way, and then just simply connect this up. So that is going to be the point, and we can label this up, and let's do that. This here is going to be C. So this is C, this is the north line, and we must show that the bearing now of C from D is this right here. It's not the inside, and that is going to be 325 degrees. Again, if you have one of the 360 degree protractors, this becomes a lot easier. So if you wanted to, you could simply now at this stage get this up, and let's spin this round. Let's put the 0 at the top, so like so, and then simply now move this into place and measure round. And as we can see from here, that's going to give me now, if I get that bang on, which is just there, that is your 325 degree bearing, which is C from D. Okay, let's move on and look at something again slightly different. What we've looked at so far are certain bearings, and I'm just going to put 2 points on the page. Okay, so if we had now A and we had B, okay, and we looked at the bearing of B from A. So of B from A, I put my north line up at A. I then consider this line down here, and I'm going to be measuring this angle. That is the bearing of B from A. Now if I put up another line just here, what we've got are two parallel lines. These two north lines are parallel, and I'll put them just on. If we consider now, let's put north and north, some basic angle facts. This is essentially a transversal. So what we're doing is looking now at angles in parallel lines. So if I put this on, let's just put this transversal on. Let's now just do that. What we've got here, and let's straighten it up just a touch. There we go. This now will mean that if this angle is, say, let's just give it a value, that's going to be, let's say that's about 110 degrees. Let's just say that that's 110. So 110. Then what we can say, as these are parallel, these are co-interior angles. Okay, so co-interior angles equal up to 180. So this must give me now an angle of 70. So what I can do here is use angle facts to work these out. So if we were told now the only bit of information we had is the bearing of B from A was 110, we could then find the bearing of A from B. So we could say now we were told, so we just have this part in the question, we could say bearing, so bearing of B from A. Remember, as soon as we see from, the north line is there, is going to be equal to 110. Therefore, and I'll just use the notation for therefore, which is the three little dots, we can now find the bearing of A from B. So let's look at that. Now here is what we can do. Consider that it's this angle right here. We're going round the outside. So all I need to do is take the 70 off from 360. So from here, what we can say now is the following. We can say it's going to be 360 minus 70, which is going to give us 290 degrees. These are now C angles, or if we like more formally, co-interior. So co-interior angles, and they equal up to 180. Now, an alternative approach to doing that would be, now if I extend this line slightly, and I'll just draw it down here, what we could look at now, if I had this, we could look at Z angles, or more formally, we could say now alternate angles. This angle right here is also going to be now 110 degrees. That's an alternate angle. So 110 degrees just here, and all I would need to do is add that to the 180 degrees round this side. I've measured this out now, and that is a straight line. Therefore, angles on a straight line equal up to, let's change the colour of that, it's not easy to see, is it? Let's grab that one. That is going to be 180 degrees. That's not an awful lot better, is it? Let's just go for black. 180 degrees. Therefore, if I've got the 110 plus the 180, that too gives me the 290. So with lots of these problems, we can use angle facts to find missing bearings. So let's go ahead and look at applying this. So we've got a diagram here. It says the diagram shows the position of three places A, B and C. So here's A, here's B and here's C. AB is the same length as AC. So we can see that that's given now to be those two straight lines. That's telling me essentially now I've got an isosceles triangle. In part A, we got the first part, and it says calculate the size of the angle marked X. Well, X is just here. In part, to explain why the angle marked y is equal to 32 degrees, which is just here. In the third part, we need to calculate the size of the angle marked z, which is just here. And then in part B, it says use your answers to A to calculate the bearing of 1, C from A, 2, A from B, and 3, B from C. Now, I'm going to attack this sort of more holistically and look at different ways that we could do it. The first thing that we need to appreciate is these north lines are parallel. So that is parallel to that, and that is parallel also. Now, what we've got here is essentially a transversal. This is a transversal. So we can start looking at using angle facts here. I'm not particularly following this in one way or the other. You can do this so many different ways and you can state so many different angle facts. Now let's consider the first thing. This now 32 with y is an alternate or z angle. So y is going to be 32 degrees. So that's what we've got, and we could say now that explain what it is, it's an alternate angle with the 32 degrees. Now, we're asked to work out the size of the angle x. This is an isosceles triangle. This angle here and this one are the same. So 180 minus the 80 minus another 80 will give us now 20 degrees. I know that this whole angle here is going to be equal to 80. So this one is going to be now 48 degrees. So all I'm going to do is go around this. I don't have to answer them all. I'm just going to do it anyway. So let's go ahead and look and find the size of the other angles. Now at this point I can use more angle facts if I want. And I'm going to kind of avoid Z for just a second because we can fill out a lot more on here. If I look as well, this angle right here, what we're going to have is the following. If this is 32, that is a co-interior angle. So this one and this one must make now 180 degrees. So this is going to be 148 degrees. Okay, that one is just there. This one is going to be now 32. It's an opposite angle right here, or it's 180 on a straight line. So that one too is 32 degrees. And again, this one right here, we're going to have now, if we add all of this up on a straight line, we're going to have on here now, if that's going to give me a total of, what's that? That's 80. So this one is going to be now 100. And we can see that loads of different ways. In fact, if we think that one and that one are an opposite angle with that. Okay, at this stage, what we need to do is just state the size of Z. We can see quite clearly Z is a Z angle with the 48 or the alternate angle. So I've gone around this a long way just simply to label up all the angles from here. So that too is 48. Just consider now the alternate angle. Here are your parallel lines. This is the transversal, therefore that's 48. Now of course we can simply work out this one from here. This is going to be 1 to 8, 48 and 80. It's 1 to 8, so this one is going to be 52. We can work out this one right here. This one, if we wanted to work that out, these three have to be equal to 90 degrees as this is a straight line. So we could say 52. So that is going to give me now, what's that going to be? 38. So let's put that one on. That's going to now be 38 degrees. And of course, we could see that this would make a right angle triangle if I just extended this. So yes, I've not answered the question in the way they want, but hopefully now you can see with a diagram like this, you can put lots of different angles on and go from there. So we've done more than we were asked to, but it's good to see that anyway, I think. Okay, in part B, we need to use our answers in A to calculate the bearing of C from A. So here is C and here is A. So what we want then is the bearing of C from A. Now what I'm going to do is put the lines back on here to show you now exactly which one that is. And I'll do it, let's just put it here for now. It's this bearing right here, C from A. So this is my north line and I'm interested in that one. So all that is now is simply now the X plus now the 32. So what we can state now, if we just write this one down, that is going to be now a total of 52 degrees. So as a bearing, 0, 5, 2 degrees. We now want the bearing of A from B. So here is B. So from B means my north line is going there, and I'm interested now in this bearing. Remember, we measure round this way right here. So at this stage, I can either add all of these up and come round this way, or I could simply subtract now the 148 from 360 to give me the rest. It's entirely up to you. You might even want to check both ways to check that your angles are correct. So all I'm going to do now is say that that is going to be 360 minus the 148, which is going to give me a total of 212. So the bearing of A from B will be 212 degrees. So I've used that, and you can use a whole host of different ones if you want. I know that this straight line here, let's just now draw this on. I know that this straight line that I've got here is going to be 180 degrees in total, and I would simply add the 32. That would give me now the bearing right the way round. And that bearing, I'll just highlight that, is going to be now this right here. That's what I've just measured from north clockwise, and I've given it 3 figures. I've just used the angle facts that we've got. We need the bearing of B from C. So this time we're interested now in B from C, and that's going to be this angle right here. So I've got a couple of choices right now. I could work one way round, or I could work the other way around. I'm simply going to consider now the bearing here, or I should say the angle here. I'm going to look at this angle right here. I know that Z is 48, so I'm going to have 360 minus the 48, which is going to give me now, what's that going to give me? 312. So that one is going to be 312 degrees. So using angle facts allows us to do that. Okay, so far we've used now either a protractor, we've used the angle facts. We're now going to move this on and use some trig. So if your course doesn't include trig, the next part is not going to be applicable. Often on foundation-based courses, this is as much as you'd be expected to do, and this would be seen to be quite a tough question. What we're now going to look at, though, is a problem involving trig. Okay, a ship sails 400 kilometres on a bearing of 075 degrees. In part A, how far east has the ship sailed? In part B, how far north has the ship sailed? What we need to do is model this situation up. So what I'm going to do is just put where it started. So if I consider now where it started, I'm going to put a north line on. So if I put my north line on, that's going to do something like so. Now this is on a bearing of 075. Now if we consider bearings, that's 0, there's 90 or 090, that's 180, that's 270, that's 360. This is on 75, so it's going to be somewhere like so. So let's just do it up here. Now what we've got is the following. We want to know how far east the ship has sailed. Now all I'm going to do is connect this up, and let's grab up another line. I'm going to connect this up right here. So we've got this bearing, and let's put a label on this. This now is going to be a 75 degree angle. So that now is 75 degrees. So all I've done is essentially measured from north, and this is now my north line, and this is going to be 400 kilometres. Now this is simple right angle trig from here. So what we're going to have here, if I just put these on, this right here, let's grab that up, this is going to be how far it's travelled now north, and this is going to be how far it's travelled east. So little right angle triangle here, and I'm going to write up our trig ratios. So using the triangles, we've got SOH, we've got CAH, and we've got TOA. So let's have a look. Firstly, if we consider now that this is the angle, relative to this angle, this is the opposite, this is the hypotenuse, and this is the adjacent. So what I want to do now is find out how far east is. So I want the opposite. So if I want the opposite, I put my finger over opposite, and it's the sine of the angle times by the hypotenuse. So this will be 400 sine now of 75 degrees. I'm going to put that in a calculator and find out this length right here. There won't be an awful lot in it in terms of the difference, but we'll put this through. So 400 sine of 75. And do check that you're in degrees mode. Shift mode 3 will ensure you are. 386.4. So let's write that down. 386.4 kilometers. Okay, and that's to 1 decimal place. And I've just found that. So that's that distance right here. This one now is how far north it's travelled. This is the adjacent. So if I want the adjacent, I'm going to now put my finger over the adjacent, and it's the cosine of the angle times hypotenuse. So 400 times cos of 75 degrees. So in a calculator again, we'll just put that in, 400, and then we've got cos of 75, and that will now give me 103.5. So that's going to be 103.5 kilometers. So you can see if we model this situation up, all I've done here, and I'll just make this more straightforward, I've said that we're starting here, I've now put a north line up, I'm on this bearing right here, which has been measured as 0.75, it's going to be somewhere up here, and I've simply completed now a little right angle triangle. Okay, so that's a typical example using trig. Let's have a look at another one. This one says Nottingham is 40 kilometres due north of Leicester. So there's north, and that's that line just there. So that's a nice north line, that's straight up. Swadlincote is 32 kilometres from Leicester, which is this one just here, and 35 kilometres from Nottingham, which is that one. We need to calculate the bearing of Swadlincote from Leicester. So what we're actually looking for here now, and we'll measure this up, we're looking for the bearing. Now, this is the north line. I'm going to measure now the bearing of Swadlincote from Leicester. Okay, and it's this bearing right here. What I'm going to do instead is find the angle in here and subtract that from 360 degrees. So what we're going to do is have this angle. What I'm going to say is that this angle is going to be angle A. This will be side A, this will be side B, and this will be side C. I can use the cosine rule here, and I can now say cos A will be equal to B squared plus C squared minus A squared over 2BC. In the formula book, you're not generally given this one. You might be, but it's more likely that you'll be given A squared is equal to B squared plus C squared minus 2BC cos A. If you are, you can rearrange it to give that. I prefer in this form. It's just easier for me to work with. So let's go ahead and find the angle A. So what I'm going to do is state now, and I'll write it down here, my bearing, so bearing will be equal to 360 degrees minus the value of A. So all I'm going to do is take that away. So what we can say is A will be equal to the inverse cosine. So all I'm doing now is getting A of, now B squared. B squared is going to be 32 squared plus C squared. C squared is going to be 40 squared, so 40 squared, minus A squared, which is 35 squared, all over now 2 times by B, which is 32, times by C, which is 40, and I can simply put this straight through a calculator. So again, if you don't know if you're in degrees or not, shift mode 3. So what I'll do now is shift cos. This is the inverse now. This is going to get to me the angle. So the inverse cosine now of 32 squared plus now the 40 squared minus the 35 squared, and then we're going to put that all over 2 times. So let's do that. 2 times by 32 times by 40, and we can get a value for that. So that tells me now that the angle just there is going to be 56.9, give or take. So what we've got then, this angle right here is going to be 56.9 degrees, approximately. Okay, therefore all I'm going to do is subtract that now to get my bearing. I want this angle right here. So 360. So 360, and if you need to use this again, shift store A. You can store that in your calculator if you want and bring it back at any time. So 360 minus my answer, and that's going to give me 303, and I'll do that to the nearest degree. So this is going to be on a bearing of 303 degrees. You would not now measure that. You wouldn't take a protractor out. You would use now the cosine rule. So the bearing of Swaddling Coat from Leicester, north line at Leicester, we measure clockwise, we measure 3 figures, and we measure from north. So to the nearest degree, so to nearest degree, I'll just put just there, that's what we're going to have. So there we go, a bit of work with bearings. We've done half an hour. Hopefully that's given you enough to get started on most problems that you'll come up against.